equals to dA by dx. Okay, and y. Okay, you get that? Alright, so then you have the area is going to be delta A, 0 to A is equals to y delta y dx. Okay, so y dx. So you just put, now our expression is not our x is in terms of t, in terms of t, right? So you have to find what is dx in terms of dt. Okay, x is equal to what, and y will be in terms of, in this case, you have y is equal to what? A sine t. So your dx is equal to dx by dt is equal to A sine t. So you get dx is equal to A sine t dt. Okay, so that's what you get. So that would be A, and then you get A squared sine squared dt. T dt. Then use the identity. So you have like cos to t is equal to cos squared t plus sine squared t equals to, you get you change the sine is equals to cos, either you get sine is equal to cos squared minus 1. So cos squared minus 1. So this one is equals to 2 cos squared t minus 1, or you change the cos is equals to sine squared plus 1, so 2 sine squared t plus 1. So you change that cos to t, so sine to t sine squared t is equals to 1 minus cos to t divided by 2. Then you just change that. Okay. Of course, in this case, there is a you change that the limit. So probably if you use that one, if you use this 1 minus cos to t, then your limit would be from k to 0. Right. So the order would be determined by the limits. Okay. All right. That is for first question. For the second question, I think this one is, I just want to give you a start for all those questions, and then I let you off. Express tangent x in terms of e to the power of 2x. This one is quite okay. Sketch the graph also should be okay, given that this show that one you just use the identity. Okay, and solve that. So number 37, this one also quite straightforward. Okay. Okay, so there's 37, the second part, by using substitution, y is equal to sine t, or otherwise show that this. Okay, so you have integral of This is number 37. 1, 0, square root of, you change it into that, so you get, of course, oops, you have y is equal to sine squared x, therefore dy by dx is equal to 2 sine x cos x. Okay, so you change that, and then you have changed that y. So the limit also from 0 to 1 of this square root of y, 1 plus y dy. So that will be equal to, change this, the limit becomes, you change that into x, so x1, x2, and then you have square root of y squared is equal to sine squared x, 1 plus sine squared x is equal to cos squared x, and then your dy is equal to 2 sine x cos x dx. Okay, and then you change that lah. Then you get sine cos, so you get, take the square root, so you get 2 sine squared x cos squared x dx, and then that becomes 1 on 2 1 on 2 sine 2x dx squared, and then you change it into sine squared. Just now we had, earlier on we have sine squared, so cos 2t minus 1. For x. Dx. Alright, and then you change that. So if I have, if y is equal to sine squared x, okay, so x is equal to, y is equal to sine squared x. So you have square root of y is equal to sine x. So x is equal to sine to the minus 1 of y. So you put the limit. So when y is equals to 0, x is equals to sine inverse of 0. Get what? Look at the graph. How does sine look like? Inverse sine look like? Sine look like this. How does inverse sine look like? Hello.
reflect it on the y equals to x.
Okay. Okay, so you have like that. So it's still when y is equals to 0, when you put in 0, so the value of x is going to be 0. So you get 0 also. So when when y equals to 1, so when y equals to 1, x is equal to what? When x is equal to, this is the sign inverse. Okay, so when we put 1, what is inverse sign of 1?
0.88.
Hmm? So what is the expression for sine to the minus 1? Like tangent to the minus 1 is half ln 1 plus x divided by 1 minus x. So what is the expression for sine inverse?
X plus set of, I forgot the rest, x squared plus
Okay,
1.
but do you get when you sub in the value of x there equals to 1? Sorry, in
Get
this case, what do we get?
ln bracket 1 plus square root 2 close bracket.
Ln
Bracket 1 plus square root 2.
square root 2. Okay, so you put that thing in lah. But that doesn't look ln of 1 plus square root 2. Okay, but anyway, oops. Okay. All right. So, but anyway, just take this thing first. Okay, you have 1 on 4. And then when we integrate, 1 on 4, and then integrate cosh, what do we get? When we integrate cosh, what do we get? Sine 4 x on 4. And then you get x. Okay, so we can change this back into y. So this is equals to 1 on 4 sine 4 x here is what? Change it back into y, then you can put the limit. Okay, and then try to prove that one. Get sine to the minus 1. Okay lah. Alright, so that is one way of doing minus 1 on 4, but this one you have to put in values and show that that thing is equals to 3 set 2, something like that. Okay. Then number 38, sketch on separately clearly labeled diagram, and then that one is okay because that will be just a pair of a function and its inverse, which is a reflection onto the y equals to x line. Prove that one is also hence or otherwise the value of proof that Find the value of that k and integral of. So hence or otherwise. So in this case, when it says hence or otherwise, normally it's best to use the results lah. Okay, so say for example, in this case, d by dx of tang to the minus 1 of x. Okay, so what you do is d by dx of half ln 1 plus x, 1 minus x. So you get 1 on 2, and then differentiate, yeah. Okay, you get 1 on 2 d by dx of ln 1 plus x minus ln 1 minus x. So you get 1 on 2 d by dx, you get 1 on 1 plus x, and then minus, but minus, so plus 1 over 1 minus x. So you get 1 on 2, 1 minus x plus 1 plus x divided by 1 minus x squared. So you get cancel, you get 1 on 2, 1 minus x squared. So that is the differential. You put in the value, okay, when x is equal to half, so you get whatever lah. 1, oops, that cancel because this is 2, so cancel with that. So it will be just 1 divided by 1 minus x squared. And then when you put in half, then you get whatever lah. Okay, and then integrate this, the second part, integrate this 0 to half tangent to the minus 1 of x dx. Okay, so what you do is you can treat it as 1 multiply with tangent to the minus 1 of x. You integrate this, differentiate that. Integrate, so you have, it will be x and then tangent to the minus 1 of x minus x 1 minus x squared dx. Then do that lah. Because you use integration by part. Okay, then number 39. Evaluate x tangent to the minus 1. Bring your answer correct to so this one is the normal one lah. So in this case also you take a product of two function. This one is tangent to the minus 1 of x dx. So you take this one to be dv by dx, that one to be this one to be u. Okay, so you get x squared on 2, then tangent to the minus 1 of x minus x squared on 2. Differentiate tangent to the minus 1 of x is 1 on 1 divided by 1 plus x squared dx. So you get x on 2 tangent to the minus 1 of x 0 to minus, in this case you get x squared plus 1 minus 1. X on 2. 0 to 2. 1 plus x squared dx. So in this case, you get 1 half integral from 0 to 2 of 1 minus 1 plus x squared dx. And then here you get tangent. Okay, when you integrate this, you get tan to the minus 1. So here is like 1 half 2. Sorry. Yeah, we put x. And then minus minus, we get plus tangent to the minus 1 of x 0 to this one done. So you have to take the limit there. That's all. Okay. Find the set of values. So that one is okay. Solve correct to 3 significant figures, the equation. Okay, so now I just another thing I want to highlight about this Maclaurin series. Yeah, in Maclaurin series, okay, in Maclaurin series, you have sometimes okay, not just in this Maclaurin. Let's say, for example, that day I mentioned that you should be able to recognize the series expansion of some standard functions. Okay, just by looking at the power series. Okay, but also in this you have to be able to, let's say for example, they did they ask you to find the integral of something, let's say. So first maybe they ask you to differentiate a function. Okay, differentiate a function, and then where in this function you know the series expansion. Okay, the series expansion you know. So then you differentiate the function, you get, let's say you get d by dx of f of x, you get, let's say, f prime of x. Okay, you know the series expansion of this. Okay, then you get the integral of this. So if you integrate this one, you will get that, isn't it? Right. Okay, so sometimes they ask you to find what is the series expansion of, sometimes they ask you to find the series expansion of this. Okay, so they give, this one is a function, let's say a series expansion of this. So how you do that, how do you find the series expansion of this? Would be to differentiate this series expansion of that. Series expansion of series expansion of f prime of x, okay, is d by dx of series expansion of f of x. Okay, so secondly, vice versa. Yeah? So if they ask you to integrate integrate a function, integrate a function known series expansion. Okay, non-series expansion, and then they ask you to integrate this. Let's say this one is like f of x. Okay, so with non-series expansion, so they ask you to, let's say in this case, f of x dx, this is equal to f. Okay, and then they ask you to find, so you after integrating you get this expression, okay, plus a constant c. So they ask you to find series expansion or series expansion of series expansion of series expansion of f of x. Oops. F of x is integral of, sorry, series expansion of f of x is integral of series expansion of f of x. So these are the another thing that you should know in Maclaurin series. Yeah, sometimes it's not easy to differentiate the function itself. Okay, so if you know the series expansion of that function, then you just differentiate that series expansion to get a series expansion of the integral of that. Okay, so let's say for example, okay, you want to find the series expansion of this, so you just integrate series expansion of this. Okay, anything you want to ask about this? Anything you want to ask?
Kita ke laporan seterusnya, dua lelaki yang membolehkan diri dari kelompok
I can't hear you. Who wants to ask?
Not from me.
Uh-huh.
No question.
Hello? Okay, all right, so in that case, if you don't have any question, then I just let you off for now. Okay, let me take attendance first. Okay. All right. Anything you want to say?
Bonjour.
Yeah.
Can you stay for a while later? Cause like I have I need some opinions from you on something.
Okay. All right. So I stopped presenting. All right. So okay. So the rest you can go and see you all tomorrow.
Thank you, Wanjo.
Thank you, Banjo.
Okay. All right.
Thank you, Puan.